The vault sits at the moral center of this design, so its responsibilities and boundaries must be explicit and supported by proof. A proper vault accepts clear custody for original PAN storage, key management, access decisions for de-tokenization, audit logging, and high availability posture. Custody boundaries draw bright lines: which subnets can reach the vault, which identities can call its interfaces, which administrators can change its configuration, and which platforms host it with what hardening. High availability belongs in policy and practice, multi-zone placement, failover tested on cadence, replication integrity verified, and performance monitored so rate limits do not create brittle dependencies. Assessors expect to see architecture runbooks, failover drill notes with timestamps and observers, database or hardware security module (HSM) attestation for keys, and a clean separation between management and data planes. A vault that exists only as a diagram is not a control, the one you can interrogate with artifacts. Different token types carry different residual risks, and the exam expects you to call those out. Irreversible, randomly generated tokens do not allow mathematical reconstruction. They rely on the vault's mapping table, which means the token alone is not a secret, but also not a clue to the original. Format-preserving tokens, by contrast, keep shape for business compatibility, and can increase display or logging risk if staff mistake a token for a masked real. Deterministic tokens, which always map the same input to the same token, help with joins and analytics, but can reveal patterns across datasets if an attacker collects many of them. As an assessor, you ask for written rationales that match use cases: irreversible for general storage, deterministic for specific cross-system joins, and strict display rules that label tokens clearly to prevent accidental disclosure. You also expect to see that format decisions are paired with compensating controls, masking, role-based access, and alerting on suspicious lookups so that convenience does not sneak risk back in. Mapping where tokens replace PAN across the ecosystem is how you prove exposure truly fell. Payment applications, batch jobs, customer service tools, reporting platforms, data lakes, and third-party integrations should all be marked with token inside or real required labels that correspond to code paths and interface contracts. In strong designs, the only places that ever see a real PAN are the vault, the payment gateway, and a small class of regulated functions such as chargebacks or network-mandated evidence submissions, and even those use time-bound de-tokenization with approvals. Assessors request message samples, database schemas, and sanitized logs to confirm the substitutions. Tokens in app tables, tokens in report exports, tokens in inter-system messages, and strict blocking of any attempt to store a real in a general store. When your map aligns with real records, you can say with confidence that business value continues while cardholder data footprint shrinks. De-tokenization is where control discipline either shines or collapses. Set strict, role-based access so only named services and people with defined job duties can request a real value, and require documented approvals for any human request, with a clock that expires standing entitlements. Record every de-tokenization with the requester identity, purpose, ticket or case link, time, client address, and result. Implement reason codes that are specific enough to audit chargeback packet assembly beats investigation, and build automated reviewers that flag unusual volumes or off-hour spikes for attention. The vault should enforce quotas, rate limits, and geo or network allow lists to make bulk exfiltration hard and noisy. Assessors read sample entries end-to-end, follow the links to business context, and expect to see remediations when a request looked suspicious. In the best programs, de-tokenization feels like a special event that leaves obvious footprints, not an ordinary function that disappears into daily noise. Vendor selection and onboarding deserve the same discipline you apply to payment processors. Validate attestations, cryptographic designs, and operational controls before adoption, and keep them current with dates and owners. If the vendor offers vaulting, review their key hierarchy, who controls key material, what hardware protections exist, and how role separation is enforced. If they offer hosted tokenization at the edge, confirm that scripts and endpoints meet integrity and CSP expectations you already apply to secure e-commerce. Assessors expect to find third-party responsibility maps that say who does what, which artifacts prove it, and how gaps are closed locally. If the vendor claims compliance, read scope notes carefully. A certificate that names their data center says nothing about your de-tokenization API gateway unless their document explicitly covers it. The most convincing evidence packages pair vendor papers with your own controls that bind usage to your risk posture. Migration succeeds when it starts with an honest inventory and ends with clean stores. List every place real PAN might live: application databases, data warehouses, log archives, support screenshots, test fixtures, legacy backups, and flat files in ad hoc shares. Prioritize by exposure and business value, then switch interfaces so tokenization happens as data enters the system rather than as an afterthought. Build temporary bridges for dependent systems while you refactor, but put clocks on those bridges and tickets that force check-ins until the old patterns disappear. As each store moves to tokens, cleanse legacy datasets by purging reals or moving them into the vault behind more restrictive controls. Attach before and after evidence to the change records table, sample queries, and screenshots that show fields changed type and values lost sensitivity. Assessors will always test the claimed last mile of a migration. Give them a straight path. End-to-end testing proves the story from generation to reconciliation. Generate tokens from sample inputs, store them in the applications that will hold them, de-tokenize through approved paths for required business functions, and reconcile that every step left the expected logs and alerts. Tests should include error conditions and boundary cases, invalid length, wrong LUHN, duplicate input, high rate requests, to demonstrate that the system fails closed and records what happened. Monitoring should light up when rules are bent: de-tokenization without a ticket, elevated volumes in a short window, or calls from unrecognized clients. Assessors ask for test plans, timestamps, participants, and specific artifacts captured during the exercises. A mature team keeps these artifacts in the evidence pack, not scattered across personal folders, because repeatability is part of assurance. Failure modes must be designed, not merely imagined, because outages and spikes hit payment flows at the worst possible moments. What happens when the vault is down? Do applications queue requests safely, present friendly try-again flows, or fall back to a local store that does not re-expose PAN? What rate limits protect the vault from cascading failures? What back-off patterns prevent storms at restart? If a de-tokenization is required for a mandated operation, is there a break glass route that still enforces approvals, logs completely, and uses dual custody? If a business team proposes caching reels to survive an outage, the answer is no, with proof of a safer pattern. Assessors expect runbooks, drills with measured times, and hard data on error budgets. The exam rewards the designs that maintain confidentiality even when availability stumbles, because security that collapses under pressure is not security. Evidence culture ties the whole program together so that any reader can retrace your conclusions. Designs should show boundaries and ownership. Configurations should show policy and force. Logs should show operations with identities, times, and outcomes. Metrics show effectiveness, de-tokenization volumes by reason code, suspicious request rates, queue depths under stress, and mean time to approve break glass events. Keep these artifacts organized by intent, reduce exposure, govern de-tokenization, prove transport security, demonstrate vendor assurance, so an assessor can follow the chain from policy to outcome. Use consistent timestamps in UTC, stable identifiers for systems, and captions that say what each artifact proves. Good evidence shortens reviews and cuts debate to the interesting parts, whether residual risks are understood and whether change triggers are tied to retesting. Two practical threads often separate strong programs from shaky ones, and the exam will probe both. First, analytics. Tokenization erases sensitive value from data lakes, but analysts still need joins. The safe path is deterministic tokens scoped per tenant or per dataset, paired with documentation of allowed joins and explicit denial of de-tokenization to analytic platforms. Second, customer service. Agents often ask for last four numbers, refunds, or verifications. The design must ensure screens and workflows display only masked tokens or gateway tokens that convey no fresh risk, and any necessary de-tokenization routes through approved, logged flows. In both cases, assessors read user stories, screen captures, and audit samples to confirm that convenience stayed inside guardrails. When people can do their jobs without touching reels, tokenization is working. Finally, keep governance alive so tokenization does not become a one-time project that drifts. Assign owners for the vault, the token service, the de-tokenization policy, and the evidence pack. Put token health on the governance agenda with a few honest measures. Percentage of in-scope systems that use tokens end-to-end. Number of de-tokenization exceptions approved and closed. Time to detect and respond to unusual de-tokenization bursts. And the count of legacy PAN stores remaining with target dates. When incidents, audits, or platform changes occur, new gateway, new analytics stack, new microservice framework, trigger review and retesting. The hallmark of maturity in a PCI context is not perfect stillness. It is controlled adaptation with artifacts that tell the story.
Close with one concrete move that cuts exposure now. Select a single PAN dataset, perhaps an older customer table still carrying reels, a support export directory, or a nightly batch file, and tokenize it end-to-end with a drafted migration checklist. Write the checklist in plain terms. Identify the source and owner. Decide the token type and scope. Change the interface so tokenization happens before storage. Cleanse historical records with proof. Deny de-tokenization to this application. Update reports to use tokens. Capture before and after queries, logs, and approvals, and schedule a recheck next month. Attach the artifacts to the evidence pack with UTC timestamps and a one-page narrative of what changed and why. That small, traceable win is exactly the kind of step a professional assessor recognizes as real risk reduction. And it teaches the organization how to repeat the pattern until tokens, not reals, become the ordinary language of your systems.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.